Okay, for the last one, which is called adaptive median filter, I think I have discussed this one in our previous chapter when I talk about median filter. Okay, so here it also repeat the same issue again. The global median filter, when it said global median filter, is the one that we have learned before, the normal median filter in image enhancement. So it's find when spatial density of the impulse noise is not large. Okay, impulse noise is another name for sus and pepper noise. Again, I have mentioned that what actually happened to what is the disadvantage of median filter is that when it fail to deal with sus and pepper noise, that is when that sus and pepper noise is come from the high density of sus and pepper noise. Okay, but in this statement they are it show that if you find out your PA and PB less than 0.2, if you refer, this one is actually a salt and pepper noise model. Okay, if you go back to the noise models, okay, you go to the this one. Okay, salt and pepper noise. So this is the PA and PB. So if the PA and PB is less than 0.2, then you can handle it by using the typical median filter. Okay, so actually that is also represent when the probability of A and B is higher, it's also represent that model actually, or that noise is consists of high density of salt and pepper noise. Okay, so this is another parameter that show you actually when you have high density of salt and pepper noise, then this global mean filter is fail to solve that or fail to remove that kind of noise. Okay, it only can work well when the PA and PB here is less than 0.2. So that's why another one of the mechanism that you can use, or you can do in order for you to solve that kind of problem, is actually by change the window size of your median filter. Okay, meaning that instead of using 3x3, you can use big window size like 5x5, 7x7. Okay, the purpose of increasing the size of the window is because when you make the window size larger, then when you do the ascending order mechanism, so that big white blob and big black blob there will actually go towards most left and most right, so it will not occupy at the center region, because center region is the one that you want to choose or you want to select when you apply the median filter. So you don't want to have some noise occupy the center, otherwise your median filter will not work, it will not work well. So that's why one way is you can actually increase the window size. Okay, but that is still can be solved. Okay, that is one way that you can handle the salt and pepper noise with high density. Okay, high density with salt and pepper noise. Okay, changing the window size. But of course the disadvantage is that is you need to know to it involve a human intervention, meaning that you need to manually select by yourself okay, what window size you want. Okay, however adaptive mean filter is more than that. Okay, before we go into the technical part, okay, and what I want to what I want to say here is that the mechanism of adaptive mean filter, um, as roughly it's work like similar that what we have discussed before, which is actually when they find out, okay, the noise is occupied at the center. Okay, then this adaptive median filter, it will adapt with that condition and it will change the behavior, meaning that instead of using 3x3, it will automatically try another window size, means that it will enlarge the window size to 5x5, and it tests again. If they find out the noise is still at the center, then it enlarge again to 7x7. So in other words, that is how the adaptive mean filter work. It will automatically enlarge the window size when they find out the noise, doesn't matter is it a pepper noise or salt noise, if these two noise is occupied at the center, it will, you know, enlarge the window size automatically without any human intervention. Okay, that's the unique about median filter. Okay, now let's discuss about the technical part about this adaptive median filter, so then we can go for the detail how actually the median filter, adaptive median filter works. Okay, before that you need to familiar with this 1 2 3 4 5. There's a 5 parameter that involved in a median filter. Okay, so again we still use the same example image like this, and of course the same things here happen here. Sorry about this one. I think this one is have been moved. Okay, it should be here. Okay, still the one that inside this red box is your this red box here is your SXY, and then any pixel inside here is the one that involved in the computation, okay, about in this filter. And then okay, this is the same ZXY. Okay, so the one that you need to familiar is Z min, Z max, and Z median. So Z min is the one, okay, again, if you take all this set of 9 item here, if you talk about 3 times 3, and then you need to compute it in ascending order. So let's say you find this is the number. Okay, this is the number 1 2 3 4 5 6 7 8 9. Okay, there's 9 item there already sort with the ascending order, like the normal median filter, you put in ascending order. So this is Z min. Okay, it's a minimum value. Z min is represent the minimum value, and then this one is Z max, and this one is Z medium. Okay, then another thing that you need to know is ZXY. Okay, ZXY is the one at the center here, XY, but when you sort it into this in ascending order like this, assume that, okay, that it might be ZXY can be here, or it can be any position at this 9 item here. Okay, it can be here, it can be here, it's up to what number here. Okay, it's depend on the value. It can be the minimum, it can be the maximum, it can be the medium, or it can be not in all min, median, and max. Okay, it can be everywhere within this 9 items. So that is ZXY. And then the other things that you need to know is Xmax. Xmax is actually the maximum allowed size of XY, meaning that in again, like I mentioned in previously, when you apply this adaptive median filter, when they find the noise that occupy at the center here, it will enlarge the window size. So means that from 3 times 3 become 5 times 5, and then it's not solved. If 5 times 5 cannot solve the problem, then it enlarge again to 7 times 7. So of course this mechanism need to stop at certain size. So that's why Xmax is the one that will stop that, because when you want to use this adaptive median filter, then you need to set your Xmax, meaning that it represent the maximum allowed size of your XY to be enlarged. Okay, if meaning that if you set the Xmax equals 7 times 7, then it will only enlarge until 7 times 7. So that is another parameter that you need to familiar. So how actually the adaptive means filter work, adaptive median filter work. So this is the algorithm. Okay, there's no equation represent this one. So this is just some pseudocode. Then this pseudocode later, maybe if you interested, you can try to convert it into program. Of course you need to build this one from scratch. Okay, so just we want to discuss about this algorithm, so then you can understand what happened is actually. So I put it here, so it maybe I can put it here, so it's better for you to see. Yep, just close that one. Okay, something like that. Okay, so from this algorithm, so you can see here that at level A, means that this one is the first instruction that you execute. Okay, you measure the A1 and you measure the A2, and A1 is defined as Z median minus Z min and Z median minus Z max for A2. And if A1 is above 0, meaning A1 is positive number and A2 is negative number, then you go to B. So meanings that if this one is fulfilled, this condition is fulfilled, meanings that meanings that if this one is fulfilled, your Z median is not occupied by the noise. Okay, just imagine that. Okay, if this is not noise, okay, if this is not noise, if this one minus this one, for sure you will get a positive number. Okay, meaning that your A1 is positive. So if you get to double confirm that one, you also measure the A2. So A2 is this one minus this one. If you this one minus this one, you get negative number, which is your A2 minus is negative number, then we can say that this is not noise, because if this is noise, doesn't matter is it come from this this side, which is represent your paper noise, and this or come from this side, which is come from your SAT noise. Okay, just imagine that, let's say this one is noise 255. Okay, this one is let's say this is 255. Okay, which is the SAT noise, and actually it's occupy all this point here, all this point here until here. So meaning that this is also 255. So if this one is 255 and this is 255, so when you measure your A1, this one minus this one, you get positive number. That's true. But if you measure this one minus this one, you get 0. So you don't get negative you get A2, where your A2 is your A2 is equal to 0, which is not less than 0. Okay, so meaning that this one is not fulfilled. So then actually by having numbers or A2 which is equal to 0, this condition is not fulfilled. So if this condition is not fulfilled, then what you do, you need to go to else. So in else what you do, you increase the window size, meaning that this is actually the indicator how the additive median filter indicate whether the noise is occupied at the center or not, meaning that 3 times 3 is not good to handle this kind of situation. So that's why you go to this, proceed with this else to enlarge your window size, and then you repeat the process again and again, and until you find out your window size is equal your X max, which is the maximum allowed window size that you have set before. Okay, which is this one. Okay, maximum window size before. Okay, that is for the case of if you find that the noise is occupied at the center. Okay, meaning that it will keep large and it will do try and error and keep repeating the process until it success to find out to indicate that actually now noise is not at this occupied at the center anymore. But of course you must put a stop criteria, the criteria there, stopping criteria, where you must stop the repetition until when the window size is equal to the X max, which is the allow maximum window size that allow in this filter. So that is considered as stop criteria, okay, of this one. Otherwise it will keep loop and loop again so many times. Okay, so that is for the case if you find out that the noise is occupied at the center. But if that is not happen, means that this one is fulfilled. So now this you can consider that no noise occupy this center. Then you proceed to level B. So what happened at the level B? Something which is good to about this filter is that, okay, the one thing that good about this filter is that at the level B, okay, for level B, okay, you can see that, okay, it's not just directly take this Z median, you know, and then you just after you identify that this Z median is not noise, then if you remember about the typical or normal median filter, it will directly set your fxy directly, you conclude that okay, you just take this one, and you will set this z median into your output. Okay, that is what happened to the normal median filter, but not for adaptive mean filter, because you can see at the level B what actually did this filter do. They will measure the B1 and B2. So what is B1 and B2? So you can see there, okay, B1 equal to zxy minus zmin, and B2 is equal zxy minus zmax. Okay, if B is positive and B is negative, then the output is zxy. So in other words, okay, this condition is actually this operation, and this condition when you obtain the B1 and B2 is actually to check, okay, to check the original zxy, okay, where this is the your zxy. Okay, if your zxy, okay, zxy okay, so if your zxy, okay, because like I mentioned previously, zxy can be here, 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 or any place in these 9 elements. So if your zxy, it can, okay, if your zxy is around here, okay, so you can see here, if your this one, okay, zmax and zmin here, for sure, if you have some, you know, some if you have some value over here which is sus and paper noise, okay, this one is might be paper noise, and this one is sus noise. So if your zxy minus this one, you get okay, zxy minus this one you get positive, and zxy minus this one you get negative. For sure that your zxy is around this, within this range, where actually it's at the point that is not noise. Okay, meaning that again, like we assume that this one is 0, you have a one black dot, and then this point over here you have 255. Okay, this point and this point. So if your zxy is among this 1 2 3 4 5 6 7 at the center here, if you minus this one and this one minus this one, then you get this one minus this one get positive, this one minus this one get negative. Then that is the condition that we validate that now if this is fulfilled, we sure that our zxy is actually is the data, or its information is not noise. Okay, so if this is noise, if this is not noise, then you what we want to proceed over here, we just make our f head equal to zxy. But let's say this one zxy is noise. Let's say zxy is actually at here, and actually is zxy is also your paper noise, so 0, or maybe let's say here beside here, but the value is 255. Okay, this is your zxy. Assume this is your zxy, which is the second last item. So this one zxy minus this one you get positive. Okay, B1 is fulfilled, but this one minus this one you don't get negative, you get 0, meaning that B2 now is not 0, so this condition is not fulfilled. So if this is happen, then you need to set your f head xy equal to z median. So what I want to highlight here, this is special about adaptive mean filter, because after you manage to handle the noise by enlarge the window size at the level A, and then when there's no noise at the center, you will proceed to the level B. But at level B, you are not directly take your z median as your output. Okay, but you have another mechanism to check if my original zxy is not noise. Then instead of taking my z median to replace that particular point at the fxy, the center point here, at the corresponding f head xy here to be my z median, it is better to take this original zxy to be set to our output, because that is the good things that we do. Because if you remember, if you talk about the median filter, the normal median filter or the typical median filter, when they are handling the, yes, that filter is very excellent in, try to remove such and pepper noise. But one disadvantage about that filter, okay, this is second advantage. Okay, the first advantage is about cannot handling the when the density of the noise is very high. Another disadvantage of median filter, normal median filter, doesn't matter the center is noise or not, you will still manipulate, or you need still, okay, I use the word manipulate. Okay, you are manipulate the set of number, you sort it into ascending order, then you are replacing this center at the output side with the z median, meaning that you are changing the information location. Okay, of course, from the perspective of appearance, okay, once you apply the median filter, yes, it can solve the problem by removing the salt and pepper noise. And because your eyes cannot detect any change there, because the output picture seem to be very good, clear from salt and pepper noise. But might be, okay, if you just imagine when we handling some medical imaging, and where the radiology thinking that, pixels number is very crucial to decide whether some patient is diagnosed with some cancer or not. So each and every value here, or the intensity value of the pixel, is very, very detailed and important to before you can make such important decision. So think about, if you apply the median filter at the pre-processing site, where median filter is actually excellent in remove all this salt and pepper noise, but at the same time you are manipulating, meaning you are replacing or changing the arrangement of the pixel. Okay, meaning that this one is already good, no noise, free from noise, actually zxy, but because you are applying normal median filter, doesn't matter is it that original image is not represent noise or not, you still replace this number with median value, which is not very good. Okay, so that's why this median filter is excellent. This adaptive median filter is more better, because it solves two things. One is you need to remember this one. One is it can solve the high density of salt and pepper noise by applying the enlarging size of window mechanism. That's the first thing. Another thing, where you can see at the level B here, it will not replace the center value with median value if your original zxy is not noise, and meaning it will remain the original data. Okay, so that's good things about another good things about the median filter, meaning that it will it will remain the original data. Okay, this means remain the original data. Most of the original data can be remain at the output side. So that is one of the second advantage of adaptive median filter.